So we had left off, okay, so we're still in 10.2, and remember we were looking at polar graphs, and we had already done, what had we done? Lines, right? We had done circles, and that's basically, oh, and we did do the limacons. We started, that's right. I want to do a couple more limacons with you guys. Remember, the limacons are really nice because you can get a fairly accurate graph, you know, by just making a walk around the unit circle. So we'd like those. They're really nice to graph. We'll do a couple more today. So that's where I'm actually going to start. I know we did question 39. Let's take a look at question 45. And we have R is equal to, we have 4 minus 2 cosine theta. And you want to make sure you take a look at your sheet. Let me go ahead and grab it just so we have it. And so right now we're in the limacons. And so, go a little bit more, there we go. And this tells you, you'll have this on the test, so you'll be able to see, oh, okay, I need to space by pi over 2 or 90 degrees. That's all my quadrantals, and I should get a fairly good looking graph. You can always plug in more points. You know, if you're like, I would like a little more precise graph, you can always plug in. But this would satisfy me on the test. So, all right, so we're going to go through here. I'm going to come back. And we're real quickly going to make a table, and we'll start at 0. Next quadrantal would be pi over 2, then pi, 3 pi over 2, and then back at 2 pi. Let me go ahead and draw in our points, our unit circle points here for the quadrantals. So let's see, this is 0 and 2 pi, 1, 0. Pi over 2, this is 0, 1, pi is negative 1, 0, 3 pi over 2, which is 0, negative 1. Okay. And so we're just going to literally plug these into the equation and get our values for R. So we know R, if we start at 0, would be 4 minus 2 times the cosine of 0. So cosine of 0, here we are at 0. Which coordinate is cosine again, you guys? X. So what's the value there? 1. Good. So you're going to have 4 minus 2 times 1, which leaves me with 2 for R. Make sense? All right, let's plug in pi over 2. What's cosine at pi over 2? We're right here. What would it be? So you'd have 4 minus 2 times 0, which would give you what? It would be 0, right? And then plugging it in. Everybody okay with that? All right. Let's plug in the pi. All right, let's look at that. What's cosine at pi right here? Yeah, negative 1. So we'd have 4 minus 2 times negative 1, giving us what? 6. Let's plug in the 3 pi over 2. What's cosine right here at 3 pi over 2? Good. So you'd have 4 minus 2 times 0, giving you 4. And then let's plug in the 2 pi. And you guys will probably recognize it's going to repeat there. Cosine at 2 pi is back here. We know that's 1. Forgot my 2 there, sorry. So it's 4 minus 2 times 1, which gives me 2. Make sure you agree with my points there. Okay. Once you get that done, you're in good shape. You just got to plot it out on the polar grid, or you can draw your own if you want, but your paper will be provided for you on the test, or the little chart will. I'm going to grab my table, and let me come over here. And let's see, let's use one of our 2 backgrounds that I like. I think I'll go with this one. And let me just paste this over here. Okay, so we're going to start out. We know that this is theta being 0. We're going to count out 2, so my first point is right here. Then we're going to come up here to pi over 2. We're counting out 4. 1, 2, 3, 4. So my next point is right here. So I'm going to go ahead and attach those and put my arrow for direction. Is everybody all right with that? Then we've got pi is over here. It's going to be 6. Let's see. 1, 2, 3, 4, 5, 6 is right here. So we're going to come back. I'm not sure I drew this very well, but that's all right. And like I said, if you want to get a better point right here, do pi fourths. But I just don't care enough to do it. But if you do, you know, hey, it's okay. It makes you better than what I'm doing. All right, and then if you do 3 pi over 2, let's plug in 1, 2, 3, 4 would be right here. I think this should be a little more circular than how I'm drawing it, but you know. And then 2 pi is right here, and we're right back at 2. So that's back here. So kind of like this. That's not a terrible approximation. I think if you were to put that in a graphing calculator, it'd probably be a little more circular, but you know, it's good enough. It gets the job done. Okay, rather boring one, right? The other one actually was prettier. It had more of a heart shape. So this one's kind of Okay. So this one looks a little bit more like a flat kind of circle. Yeah, it's your most boring case. So, all right, then the last one we're going to do is the neatest one. It will have a little loop on the inside. So I want you guys to see that. So let's move over, and again, I forgot. Let me put the instructions down so you guys have it. And so this one says, I forgot to say, identify and graph each polar equation. Okay. All right, and so the last limason we'll do, let's take a look at question 47. We've got r is equal to, we have 1 plus, we have 2 sine of theta. And of course, if you go over to your sheet, you should recognize it. Again, same thing, we're just going to recognize it as a limason, so we know we're just going to make that walk around the unit circle. I'm actually going to go back real quickly and borrow my previous points here from the quadrantals. Just take that on over. Okay, and so again, we're going to make our table. I should have looked in the book to see if they did. Oh, good. They did theta r in the book, too, because I was like, which way are they doing it in the book? So I'm actually glad I did it that way. Sometimes people will do r theta because that's the way the polar coordinates are written, but we know we always put the theta in first. So I like to do the theta and then the r. So the book did the same thing. So, okay, so let's make our walk around the unit circle. So we know we're going to do 0. We're hitting all the quadrantals. And then let's just plug them in. So here we're going to have 1 plus 2 times the sine of 0. So we're right here. Which coordinate is sine? Y. Good. So what's your value there? What's your y here? 0. So you would have 1 plus 2 times what? 0. So you get 1. All right, let's plug in the pi over 2. So now we're right here. What's your y coordinate there? 1. Good. So you'd have 1 plus 2 times 1 giving you what? 3. Let's plug in pi. So 2 times the sine of pi. So we're right here. What's the y coordinate there? 0. Good. So we're back at 1. Let's plug in the 3 pi over 2. So we're looking at the y coordinate right here. What do you guys see? Good. So you're going to do 1 plus 2 times negative 1, giving you what? Negative 1. I'm always like, oh, when I see the negatives, because it's a little harder to graph them. Not terrible, though. And then let's plug in the 2 pi. And we know at 2 pi we're back here, so we're back at the y coordinate being what? 0. Good. So you're going to have 1 plus 2 times 0, so you're back at 1. So that's all we need right there. We just need this table. Okay, so are you guys okay if I go to a new screen? All right, so we'll go ahead, we'll plot this out again, get a nice background for us. Okay, so we're going to start out at 0. This one's going to be a little more scrunched in because we're only going out a distance 1 here. So starting there. Then we're up here at pi over 2. Let's see, we're going to do 1, 2, 3. So right here. So it's going to do like that. You guys see it? And then let's see, at pi, we're going back to what, just 1, so more like this. And then at 3 pi over 2, actually this isn't bad. -1 just means right in here. Are you guys following me? By which part? So r is negative, so what does that mean? Go in the opposite direction. So I'm counting up 1 in the opposite direction. Make sense? Yeah, okay. So then you're going to come from here, and then what are you actually doing? Now, this is a little interesting because you can't quite see it here, but you're kind of coming out a little ways when you hit that -1. And remember, you're going like this. I said this was going to be easy, and I wasn't really telling the truth because this is a little more difficult. Your theta's going from pi to 3 pi over 2, right? But because your r's are negative, you're actually where? Mirroring over where? On that side. Do you guys see it? And so it actually comes up a little ways. It comes up, and then it's actually going to hit this way. And I know that from experience from graphing them because they kind of have that heart shape. If you're not sure, you can plug in some other points to just kind of check it. So you can always plug in a few more. But it's going to have, when you realize it's going to go inside and it's got that inner loop, it's still going to have that heart kind of shape. So and I'm not looking, it doesn't have to be perfect on the test. I just want your points to be correct and you have a fairly decent looking graph. Okay, now we're going back to 2 pi. And let's see, at 2 pi, we're getting 1. So that means it's going to curve around here because remember, again, you had negative r's, correct? So you were where? Your theta's going from 3 pi over 2 to what? 2 pi. So where are you? You're over here. Makes sense? And so it's going to kind of come back around, and it should have some symmetry, and so it should loop back like this. Does that make sense? Okay. So it's I guess that's a little more difficult to graph because of those negative signs, but they don't always have them. Sometimes they do, sometimes I guess they do, though, to make that inner loop. So it should kind of, when it has an inner loop, just remember it's going to have a little bit of a heart shape, and it is going to have the symmetry. So you'll just go in and loop it and then close it. Everybody's okay with that? Got it? Okay. All right. Now we're going to move into, these are the fun ones. So, or I should say they're the most fun to graph, but they're fun to look at. They're very pretty when you graph them. They actually do have like a flower sort of shape to them. And so we're going to come up a little ways and we're going to look at the rose curves. The way that I'm telling you to graph these really is the easiest way to do it. You'll get a really nice set of points this way. Again, you're going to make your way around 0 to 2 pi, but you're going to space these a specific way. And so what I want to kind of draw to your attention here is the K here. Let me kind of point it out. Do you guys see the K on the theta? That becomes important because that, notice, is related to how you're going to space them. And since you'll have this on the test, you just want to make sure you know how to use the sheet. But it will be pi over 2K will be your spacing. And it just happens to work out that they come out. I don't know when I finally discovered that, but they come out really nicely when you do it that way. Then the other thing is the K actually makes a difference whether K is even or odd. If your K is odd, then that's the number of petals you have. So if it's like 5, you have 5 petals. If it's 3, you have 3 petals, whatever. But if your K is even, like 2, it actually doubles. So you have 4 petals. Or, God help you, if it's 4, you'd have 8 petals or something like that. We're not going to do anything real extreme, but if it is an even number on the K, then you actually double it to get the number of petals that you're going to have. Are you guys okay? And other than that, it's basically like doing all the rest. It's just the spacing that's a little bit different. So we'll do at least 1, maybe 2 of these, and then I'll show you the last few. Okay, so let's take a look here. Again, basically, it's identify and graph. And we'll start out, let me see where we want to start with it. Let's do an even one. So let's do question 51. We have r is equal to, we have 3 cosine of 2 theta. And so right away, the nice thing is, you're like, well, how do I know that this isn't a circle? The way you can tell that it's not a circle is that you have a number in front of the theta. That's how you know it's a rose curve and not a circle. So you realize right away from your sheet that K is what? 2, which means you have what? 4 petals. So since it's even, you're gonna double up here. You know you want to space this from 0. Let me see what I put on the sheet. Okay, all the way 0 to 2 pi. Okay, so we're going to do 0 all the way back to 2 pi, and we're going to space it by doing pi over what? 2k, according to the sheet. So we're going to do pi over 2 times 2, which is what? Pi fourths. Make sense? So that's just happens to be the nicest way to space them out. Okay, so we'll start at 0, and then we're going to space completely by pi fourths all the way till we get to 2 pi to get a fairly decent looking graph. So a couple things I see I need. I'm going to go ahead real quickly over here. Just in case, I'll go ahead and put my quadrantals in. And then I'm going to go ahead and draw my 45 because I'm spacing by fourths. Makes sense? So I think that's the one I'm going to need. So I'll do my 45, which is 1 root 2, and I'll just put my SOHCAHTOA down so I can generate everything I need. Okay, so we're going to make a quick table. And this one's going to be, I think, a tiny bit more tedious. We'll see how many we have to do. But you do have to make a full rotation on pi 4, so it's going to be a lot of information. So we're going to start at 0. Then you're going to do what? 0 plus what? Pi over 4, which is pi fourths, because you're spacing that distance of 45 each way, right? Then you would do pi over 4 plus pi over 4 is how much? 2 pi over 4, which will reduce to pi over what? 2. And I think it's handy to have them both down because it's better to have the 2 pi fourths when you're adding, but it's easier to know the pi over 2 is the quadrantal. So I'd have them both. Then take your 2 pi fourths since it's already got the right denominator, and what do you get? 3 pi over 4. Make sense? Then 3 pi over 4. I didn't write that right. Here we go. Plus pi over 4 would be 4 pi over 4, which is really what? Pi. Does that make sense? So you're halfway. Let me go ahead and continue on over here. So then 4 pi over 4 plus pi over 4 is how much? 5 pi over 4. Then 5 pi over 4 plus pi over 4 is 6 pi over 4, which is really what? 3 pi over 2, and then 6 pi over 4 plus pi over 4 is what? We're almost there. 7 pi fourths, right? And then 7 pi over 4 plus pi over 4 we know is 8 pi fourths, which is what? 2 pi. And I know that's a lot of points, but you'll get a nice looking picture from that. And it always works out pretty well. All right, the annoying part is we got to plug all that in. So, let me go ahead and grab the graph. I'm going to go to a new screen just so I have a little bit more room. So I'll take all this. And then let me grab this stuff. Okay. All right, so don't forget that we are plugging into the original equation here. That's how you're getting your R values. So we're going to start, we're going to plug in, we're going to have 3 times the cosine, we're going to do 2 times, what are we starting with? 0, right? That's your first point for theta. And so you get 3 times the cosine of 0, correct? And we know cosine of 0 is really what? 1, right? Because you're right here on the unit circle. Bless you. So at least we got 1 point. First point starts us out where? At 3. Make sense? Are you guys all right? Okay. All right, let's plug in the, the next one, which is pi fourths here. So we have 3 times the cosine of 2 times pi over 4. So that will reduce to 2. So we've got 3 times the cosine of pi over 2. Does everybody see that all right? And of course, what's cosine at pi over 2? So you get 0. Make sense? I may not even need that 45. We'll see. All right, then we'll plug in, kind of coming, I'm trying to give myself a little more room. Let's plug in the next one, which is the pi over 2. So we'll have 3 times the cosine of 2 times pi over 2. So that'll cancel. So we're looking at what? Cosine of pi? What's cosine at pi, guys? -1, so you get -3. Make sense? So then we'll do 3 times the cosine. Next one is 3 pi fourths. So we'll have 2 times 3 pi over 4. Notice that will reduce down, so you wind up with 3 times the cosine of what? 3 pi over what? 2? And what's cosine right here? 0. So you get 3 times 0, which is what? 0. I forgot that's the whole reason I did that, so you don't have to mess with the 45. So you wind up at the quadrantals. I couldn't remember. Okay. Now I'm running out of room. Let me just move again. It's really giving me a fit today. Try again. Okay, so this is turning out. All we need is this. And I do need the equation here. Okay, so let's plug in. Next one is pi. So we have r is equal to 3 times the cosine of 2 times pi. So we have cosine at 2 pi, right? What's cosine at 2 pi? Yeah, right here, right? So it'd be 1. So you get 3 times 1, which is what? 3. You've seen the pattern. It's 0, 3, but the only thing you have to be careful of is where are the negatives. So, you know, I would plug them all in just to make sure so you have it right. So we have 3 times the cosine. Next one we're plugging in is 5 pi over 4. And so you get 3 times the cosine of 5 pi over what? 2. Now what is 5 pi over 2? It's 2 point what? 5, which is right here. Do you guys see it? Because that is 2.5 pi. Make sense? And so you would get what? 0. So you'd have 3 times 0, which is 0. And you're probably picking up the pattern. You can take the zeros for granted. At some point, you can say, I know it's going to be 0 there. But, you know, we got to do it fully out at least one time in class. But I don't mind if you see it. And the only thing you've got to check is the ones with the 3's because you want to know if it's positive or negative. That's the only thing. Okay, so let's do 3 times the cosine. Next one is 2 times 3 pi over 2. Those cancel. We've got 3 times the cosine of 3 pi. We know that's right here. Yes? What's cosine there? Negative. So it's going to be -3 there. Next one I already know is what? 0. Why not take it? Are you guys okay? Yeah, you see it because it'll be 7 pi over 2 once you reduce it. And so this last one, let's do r is equal to 3 times the cosine of 2 times 2 pi, which is how much? 4 pi? Back here, yes. And what do you get there? +1, right? And we've got it. Are you guys all right there? So they're really pretty, but they do take a little bit more work because you got only in that you have to get more points. Okay. So the 3's are going to be the links of the petals and then moving back and then looping back to the next petal. That's kind of how it works. And you will see it right now. So let me actually do one above and one. I'll use this one. What are we using? Pi fourths and okay, so I can use this the other one then. sometimes I prefer to draw mine in, and sometimes I like it when they're already given. So the ones I give you on the test, you've got them all nicely in there, but this one's fine because it's got the 45 nicely marked. So I'll put my first table up here. Oops, that's too small. I can't see that. Okay, and then let's grab this one. I guess I'll just put it on the other side. And we'll put it over here. All right, let's see if we can get this. Let's use a pretty color since this is going to be, I'll use purple. All right, so, right, we might as well spice it up a little. We're going to make a flower. Let's make it a pretty color. All right, so we're going to start with 0, which we know is right here. Do you guys see it? You're going to count out 3. This one's positive. So you're going to do 1, 2, 3, and so this is your first point. Make sense? Okay. Next thing, draw in, go ahead and put in your pi force here. I'll try to make it look pretty, so I'll be consistent here. So here's your pi force. Again, what's happening as you start approaching from 0 to pi force, you go back to what? 0. So all you have to do is kind of take it back to right here because you're at 0. Does that make sense? So pi force 0 didn't go anywhere. You got it? All right. And then now we've got pi over 2. Here's where things get interesting, but you can start seeing the motion. Why is it negative? Because you can tell it's going to loop what? Down. So you can kind of see it. So 1, I'll go ahead and mark them both. See if I can trace today. Yeah, that's pretty good for me. Okay. So 1, 2, 3 down. And since your theta's here, where are you mirroring it? Right here. Do you guys see it? So you want to kind of stay in between that, in between those two. So you're going to kind of come down and come back this way. Make sense? Okay. So then what are we doing? We're moving towards 3 pi fourths is our next one. So we know this is 3 pi over 4 right here. But since we're dealing with negatives, I better go ahead and just take it on down. Okay, so our theta's moving this way. Yes? We're mirroring it where? See how I like having the lines because you know your pedal should not extend those lines. Exactly. Exactly. It's going to come back around and close. Do you guys see it? Because you get 0 there, so it's going to come back around and close. Make sense? But you can see how that's important to know how it's moving. You've got to know where it is at that point in time. So it makes a difference. Okay. Then our next one is what? Pi. And at pi, we're going back out. Let me come back out this way. Bless you. 1, 2, 3. So here. And so we're just going to mark it. We're starting back there, right? So what's happening is you're going from 3, where was it? 3 pi over 4, which I didn't mark right. I said it, but I marked it wrong. 3 pi over 4 to pi. So you're moving like this is your theta, right? But because you were in negatives, were we in negatives? Wait a minute. No, we were not. Okay. Never mind. Okay, so we should move this way. We were out of the negatives. But don't exceed those lines, you guys, because if you exceed those lines, it's not correct. You know, it's actually going to stay within those lines there, between those pi fourths and the pi's. It stays in there. So it's nice to kind of have them marked. Okay, so there we go. And it should be symmetrical. I'm trying to draw it with some symmetry here. All right, then what's next? We're going to 5 pi fourths. We know 5 pi fourths right here, correct? And we're going back to what? 0. Makes sense? All right, then the last one, now we're hitting back in the negatives. We're going from 5 pi fourths to what? 3 pi over 2. So we're mirroring it where? Up here at the top. Does everybody see that? So when you count the -3, you're actually going to count it 1, 2, 3, right? And you're going to move what? this way. You got it? Yeah? Okay. And then we're going from 3 pi over 2 to what? 7 pi over 4. And because we were in the negatives, right? Did I do that right? Did I do, was I in the wrong spot?
3 pi over 2 to pi over 2 since it's negative, or do you go to
Let me see, I may have done it wrong. It's the last one, right? Let me go back a minute. That's the one you guys are questioning, right? Okay, let me see. Okay, so we were going, I forgot where we were. Oh, yeah. Yeah, we were going from 5 pi fourths to what? 3 pi over 2. We were right here. And then it was -3. So at 5 pi fourths, -3 should be, yeah, it should have been up there. Do you guys see it? Yeah, that was right. It would be up here. Why? Because at 5 pi fourths, you're going in what? Oh, it's at 3 pi over 2. I see. Sorry, yeah. You leave that and get rid of that. Okay. Still didn't get it. It's right there at 3 pi over 2. Yeah, I'm sorry. 1, 2, 3. Here. Okay, I got it. So we're moving up. Yeah, thank you, Alexis. Yeah, shouldn't have been that hard. I just can't read my own graph. All right, so we have this, and that's because of the mirroring I was trying to show you. And then from 3 pi over 2, okay, we've got our 7 pi fourths now. So 3 pi over 2 to 7 pi over fourths, we're going back to what? 0. Does everybody see that? Because of the negatives, it's going to be up top. You with me there? Here to here. Okay. And then finally back to what? 2 pi, and what's that going to do? Close the graph. Do you guys see it? That wasn't the smoothest job. I wish I had done that. Made that one mistake at 3 pi halves, but. So just take that part out. Other than that, it was fine. Maybe I'll do that in the video, actually. I'll just take that little blurb out where I messed it up. Okay. Now, you can put them in your graphing calculators, but remember, we're kind of moving away from using graphing calculators, so you shouldn't be using those. You want to make sure you're pretty comfortable, especially since we're not going to have them in calculus anymore. So make sure you can do it by hand so that you're okay graphing them. So when you get to Calc 2, right, you're going to be like, oh yeah, I already know how to do these by hand. Okay, I'm going to stop and restart here. I have one more rose curve I want to